Hey everybody, this is Dave Cooper, and we are in central London at Tottenham Court, which is a new train station in London. And standing with me is Jaimie Johnston, Bryden. Jaimie, thanks for joining us.
Hi there, thanks for coming down.
Yeah, thanks for having us. So, Jaimie, this is a really special project, and we're going to get into some of those reasons why it's so special. But why don't you tell us a little bit about Bryden Wood and what is this project all about?
So this is the Elizabeth line, so it's the new rail line that runs east-west through London. So London's famously had a poor interconnectivity across the middle of the city centre. So this project opened only a few weeks ago, and it's a massive infrastructure project, very complex, building something that runs straight through the middle of London, weaves its way in between all these original buildings. So delivering this has been a massive undertaking, and it's finally open, and you can see the quality of it.
Sure. So when I step back and we take a look at the panels, this is everything that you guys were working on within the station to give people a reality check of how much work goes into this. There's 27,000 of these panels, yes?
Yes. Yeah, and you can see the geometry of them is incredibly complicated, so there's not many repeats. So once you get into the kind of standard panels over there, there's repeatability, but as you come around these corners, trying to make sure that all of these lines matched perfectly was incredibly difficult, and you can see just the complexity of the shape, the geometry. Installing it was a massive task.
This is something you've been talking about, right? The digital to physical, and this is something that typically would not be able to be done by humans just directly because of all the geometry and angles that are involved.
Yes. Yeah, so we were brought in by Langley, so they won the contract to deliver Tottenham Court Road, Liverpool Street, Whitechapel stations. It's the original concept design. These panels were much thicker, so they were incredibly heavy, which meant that every panel would have been a mechanical lift. And then the supporting framework that sits behind it was also incredibly heavy. So every time you drill into the tunnel, that's an opportunity for tolerance issues, people working at height, all the rest of it. So we were brought in to see whether we could optimise the design, reduce the weight of all the components, and then work out if there was a better way that we could install the panels much quicker and faster. So that was some of the stuff that we then developed in the background. So behind this, there's this incredibly sort of complex support system that we helped develop, and then obviously develop the design of the panels themselves.
So the tunnel itself is a granite concrete tunnel, which is not even in any stretch of the words to do something this accurate. So there was a whole lot of thought that had to go into how do you set these panels on a very uneven surface running through here. Walk us through how that happened.
So behind this is sprayed concrete, which is impossible to get sort of completely flush and level. So one of the big challenges was how to install something this accurate against a background of sprayed concrete, which was all over the place. So one of the big things or steps forward we took was to say, well, if you put in a rail along the top and got that absolutely lined and leveled, so you know exactly where that rail is, you can fix the points on the floor, so you know where the bottom is. You've then got completely fixed locations, and now you can fix the ladder frame that sits behind that. All of those points are now completely where they're supposed to be, which means that the panels will now always fit. So one of the big steps forward was sort of redesigning all of the kind of supporting stuff to get back to zero tolerance. And you can see the kind of dimensional accuracy of these panels now. So to get that to work, we then were driving all of the processes downstream directly off our digital model. So all the molds for these were 3D printed direct from our files, or they were CNC cut direct from the files. So you had an absolute accuracy of the panels then. You knew that all the points were fixed, and suddenly that made the whole thing much, much quicker and easier to install.
So just to clarify, you ran a fixed beam at the top to start your points. And then, as we know it, where everybody's walking on the platform, that's a fixed point. So those were the two areas where you knew for certain that those would be two fixed points throughout the entire station that you could set all your lines and be able to hang these panels, correct?
Yes. So then we made, the original design had a very heavy support frame that sat behind it. So we redesigned that to be laser cut from thin steel. So suddenly the weight of that came down, but also you can make that incredibly accurately. So we've then got fixed point here, fixed point here. We laser located all of the fixing points on that ladder frame, and you're now back to absolute accuracy. So in the original design, the expectation was that each one of these panels would have to be locally adjusted, but because we could fix all the supporting points, you didn't need adjustment on the panels, which made them much, much quicker to install. and that sort of unlocked the productivity.
Right.
You can imagine working down here. You
Yeah.
know, if panels don't fit, that's a massive problem.
Right.
So everything had to be very, very well coordinated, pre-kitted, logistically controlled, and the idea that all these panels would always fit. So of the 27,000 panels, I don't think we had any that
didn't fit
the first time. Which
how,
was
how do you get the dimensions of the panel? Like what do you do to actually get all of these shapes back into a system, into a mold, and then it's like paint by numbers, put it back to where you took that?
Yeah. So we had, we actually had an incredibly sophisticated digital workflow. So we had an automated checking of the as-built tunnel compared to as designed.
Yeah.
So we knew where the tunnel was out of tolerance, and we could adjust our components locally to account for that. Once we then had the SolidWorks model with all that geometry, everything was then driven straight from that model. So all the numbering of the components, the design of the molds, the logistics, everything was driven completely off our SolidWorks model. So when they did the setting out for these, the setting out points were sent to a little robot that roamed around, pinged a couple of lasers. So again, we knew that all the fixing points would be exactly where they were supposed to.
From where they go. And so these panels on the facade here, it's actually layered. There's a big panel underneath this as well,
Yes.
correct? What is the purpose of that?
So behind that, so these ones, you can see how many panels come together at these points. So we actually designed a large piece of glass fibre reinforced concrete that sits behind this that creates that shape ready for these panels to sit on. So actually the support system looks as beautiful as these panels.
Right.
It was a shame we had to cover them up actually because they're these incredible sort of sculptural shapes. We couldn't have described it in drawings.
Right.
Because you can imagine it's impossible to draw enough kind of sections through it to describe it. So the only way really to describe it was using three-dimensional models, using that to drive the kind of all these manufacturing processes. So you can imagine, I'm not sure how we would have done it without being able to do the digital
to physical
workflow. Yeah, digital to physical.
Right, the digital to physical. Reducing the material used on the panels, I mean, is a big cost savings, I would imagine, for the City of London.
Yeah.
As well as not just the panels are you saving the material costs on, but it's the fasteners as well, yes?
Yes. Yeah, so because we simplified all the substrate, we actually got the number of fixings down by a factor of 24. So that's obviously a massive productivity gain. It's a massive health and safety benefit.
Yeah.
We tuned the panel design. We actually did bomb blast testing to work out how thin we could make the panels while still meeting all the technical requirements. So in the original design, every one of these was a mechanical lift, and by the time we'd simplified it and optimized it, most of these then became manual lifts, which makes it much quicker to install on site. And obviously stripping out material means there's less cost, there's less carbon, and you can get obviously loads more panels for the same amount of material, which is a huge benefit.
So basically, how many people would it take to put these panels in place?
There was a little team of sort of 5 or 6
to put the panels in
the crew putting them, but they actually, so Lang & Rourke had a GRC UK facility where they made all the panels. They actually had to open up a second factory to keep up. Because the install time was so quick because of all the pre-kitting logistics and everything.
And the accuracy.
The team was incredibly fast, because they weren't having to adjust every individual panel.
Right.
They were tearing through these things. So, you mentioned there's like 20-odd thousand of
27,000 of these panels. Well, Jaimie, listen, we appreciate you taking some time, letting us come down here, checking out Bryden Wood, the work you guys are doing there, the digital to physical, speeds up the process, cuts down on waste, adds, to safety of the labor force and so many other things. So we appreciate it. Thank you so much.
No, thanks a lot. Thanks for coming.
All right, there you have it. Tottenham Court, Central London. I'm Dave Cooper. Thanks for watching.